Welcome. Thanks for coming. Can everybody hear me? I don't like using mics. Okay, it's just me. My name's Derek Ashmore. I'm from Asperatus Consulting in Chicago. We're going to talk about application deployment patterns. And I realize wires got crossed somewhere. The title in this thing was an old title. And we apologize for the confusion. We are talking about and mentioning our application modernization framework, but we're really zeroing in on deployment patterns. This isn't an intended shift in topic. And I need to start my timer so I know if I'm going over. Oh. Okay, using the mic.
I think you can hold it to you feel comfortable.
All right.
Whatever you want.
Okay, got it. All right. Sorry for the deviation. Everything we're going to talk about here, it comes from the field, right? This is what we at Asperatus do day in, day out. Tried and true at several different enterprises. No ivory tower stuff for me. Basically, I start out with some tales from the field, and let's talk a little bit about infrastructure as code. And I hope that 90+% of you does infrastructure as code these days. We certainly do. We have a consumer product firm client that basically goes to the extent of rebuilding their complete cloud footprint in a different region every 2 weeks, just to prove that they can do it, and they test it out. That includes their network infrastructure, but it also includes all their applications. All right, so they use some of the deployment application deployment patterns we're going to talk
What
about.
industry is that? What
I'm
industry
sorry?
is that for?
I'm sorry.
Did you say what industry are they in?
They are a consumer products firm. I'm not going to get more narrow than that. All right. I have contractual non-competes and
Yeah.
stuff. I can't mention specific names. Another place that we draw on for experience, we got a financial institution client, a bank of sorts that basically we give their application teams starter building blocks and starter pipelines so that when they deploy their applications to the cloud, to AWS, they're not starting from ground zero. And then another example I'll tell you about is a fast food franchise. And I don't mean the place where you physically pick up dinner. This is corporate support. All right. Basically, they want to be nimble. And they do a lot of experimentation. So they have basically automated their cloud setup so that if somebody gets a new business idea, they can basically provision a new account, complete with internet ingress, egress, if that experiment needs it, complete with on-premises connectivity, complete with guardrails so that they can't do anything that's going to sacrifice security. Something along those lines. All right, fast forward to how do we do this? I'm a top-down person, so I'm going to start from the top and then drill down. We've basically developed an application modernization framework that basically takes infrastructure code, the deployment patterns that we're going to talk about today. We have embraced immutable architectures. And what that means is when we deploy applications, we don't just like change content of what's running on instances, things like that. We completely replace the infrastructure that an application runs on. Show of hands, who uses infrastructure or immutable architectures, where they come from? Okay, I'm hoping to convince people to up that percentage. And we also leverage centralized infrastructure code libraries and pipelines so that application teams don't have to build what we built. And basically, we roll that out to enterprises at scale. So essentially, we combine an infrastructure code stack. Most of our customers want Terraform. That said, I don't want to start any religious wars. There's nothing wrong with cloud formation or CDK or Pulumi or any of the other tech stacks that you could choose. The hot button for me is that you automate it, you don't do it manually. And then we combine a application deployment pattern list, and there are primarily 4. And we're going to go through each one of them. Basically, the one that everybody always starts with is basically the all at once. I call it spray and pray because that's essentially what you're doing from a risk standpoint. But basically, it's take the app down, put a new copy out there, make the new version live. And then there are a couple of evolving patterns that we're going to talk about. Beyond that, we also combine the infrastructure code modules that we built, plus the pipeline templates and the CI/CD tooling. And most of our customers, most of our AWS customers use Jenkins. Having said that, I don't want to start any religious wars. I have no association with Jenkins. Basically, from my perspective, we like CI/CD tooling. I don't care whether it's Circle CI, whether it's the AWS Code Splat tools, or which tools you use. We just don't want the problem of, well, you know, the deployment works if Fred does it on his laptop, but not Joe. Right? We don't want those kinds of issues, and we also want audit history. All right, let's talk about application deployment patterns. I look at it as kind of an evolution. Okay, to start off with, everybody does the quickest and easiest thing, right? Basically, you take the old one down, you run something, it pushes the new version, a new application version out, and brings it live. It's quickest and easiest, which is why everybody always starts there. New applications typically start there because they don't have a user base to really care about when they're new, or at least not as much of one. And then when you get further in evolution, you get down to rolling updates. All right, and what that means is you're introducing the concept that you're updating an application without an end user outage in the middle. And we're going to go through that a little bit, which gives the end user benefit. It still leaves you a little bit of business risk if you deploy something that has a defect in its new version. And then further above that, you get into what's called a blue-green deployment pattern. And what that does is introduce the concept of increased business safety. All right, because what that means is, and this plays on the fact that we use infrastructure, immutable architectures. Essentially, we have 2 copies of an application up at once, 2 versions, right? The old version and the new version we're going to. And the reason we do that is that you can do private testing on the new version before it goes out. Right, so it increases the chance that you're about to release a defect, that you discover that you're about to release a defect and don't release it. And then some of our customers evolve beyond blue-green to Canary. I get into religious debates sometimes. Some people I talk to think that Canary is completely separate than blue-green. I think that Canary is really a version of blue-green. Instead of an on-off switch for the light, it's like a dimmer kind of switch, right? Where you gradually move users from copy A to copy B. Rolling updates. So let's put on our rose-colored glasses. And our fast food franchisor customer uses this. Let's say you've got, just to stay consistent with the slide, let's say you've got 5 copies of an application up there and running in a distributed load balance kind of way. What rolling updates really means is you're changing each one of those 5 copies one at a time. So the user doesn't have an outage. You're never completely out. During the deployment, you do have situations where one user will get the old copy and one user will get the new copy. But essentially, that's what happens. This particular customer manages those deployments through Elastic Beanstalk. Once again, I don't want to start any religious wars. Those who are using Kubernetes comes with rolling update deployment kinds of features more built in, and that's another way to implement something like that. Blue-green basically works by having separate copies, an old and a new typically, in production live. And basically you have some sort of ingress controller, which is really at the top center on the right side. It can be something as simple as DNS. You know, Fred.com points to blue copy or points to green copy. It's just a switch. What that means is you can test the up and coming copy privately without publishing it to the masses. What it also means is that if you discover that you missed something in testing and you deploy a defect, backing out is just switching back. All right. So you can do something as a DNS entry. Route 53 works, or most of our customers do some sort of custom DNS. It doesn't matter from that perspective. It's just a DNS entry. The other flavor of ingress controller I see is Nginx. And if you're doing Kubernetes, that's a popular choice. It's not the only choice, but it's a popular choice. Either way, you get the idea. And Canary basically is blue-green, except that you're not doing the on-off switch. So suppose I take 1% of our users and I switch them to the new version and I start looking for errors. Are they getting errors? Are things working for them? When I'm comfortable, I may up that percentage from 1 to 5 or from 5 to 10 or whatever that is. Some of our customers want to do, and this is where the ingress controller becomes more important, because some of our customers want to do more sophisticated rollover strategies. Like for instance, they may have identified users as beta test users, right? That might want to, that volunteer to use the beta test version, and you want some sort of sophisticated ingress controller. DNS won't do it for you, or Route 53 weighted router won't do it for you in that case. If you need to differentiate between user Fred and user Joe or user Sally to determine where they go, you need a good ingress controller with sophistication to do that. Now,
Quick question on that.
yes, sir.
Where do you put that switch? Does it sit in either environment or does it sit up where the DNS takes place?
All right. The question is, let me go back. The question is, where do you put the ingress controller? It's either DNS, and Route 53 gives you some primitive weighted routing kind of thing where I could basically say, okay, 1% goes this way and 99% goes that way. Or you stand up a separate ingress controller All right, and Nginx is popular, but once again, there are other options. I'm not trying to get into a religious war, but essentially, you stand up something that determines, that does the traffic cop maneuver, and that's really common in a Kubernetes deployment, because in that kind of situation, the load balancer is really in queue. And you've got two different essentially deployments for your application that the ingress is choosing between. Does that answer your question?
It's not sitting within those environments. It's another
I'm sorry?
environment. So you have to hit this other environment first, get your traffic cop, and then you go to the user.
Yes. Yes. Basically, I didn't draw it on the picture, but all your users are coming into the ingress controller on the top right. Okay, slides are made available after the talk. I'm not going to have time to go through this line by line, but just like every other decision that we make as geeks, your pipeline decision has pluses and minuses, right? Costs on the one side, spray and pray is always simpler and cheaper, but has costs in terms of end user outages, has costs in terms of business safety. And as you go up the evolutionary scale, the choices are different. Yes, it takes more to initially do, which is why we put the framework together, so that application teams don't need to do as much to get those off the ground. But basically, you increase complexity, but you increase business safety, and you increase end user availability. Yes, sir.
When you're talking about applications, does that include database infrastructure?
I know where you're going. The question is, does that include database infrastructure? And I don't want to eat into somebody else's time, but you notice
Oh, there it
in all these diagrams,
is. Old guys,
right? So basically, one of the things that you need to be wary of when you use Canary deployments or blue-green, you need to make sure to be prudent database designers so that your changes to your application are backward compatible. All right. Data is always a sore point. And there are ways to deal with databases in scenarios like this, but it takes that's a whole separate talk. All right. Yes, sir.
Talking about these different deployment strategies, we're really trying to get our developers focusing more on feature flagging and less about the deployment strategy. How would you consider using feature flagging in this deployment strategy that we described?
The question is, where does feature flagging fit in to this deployment strategy?
Yeah.
And to my mind, that's a separate thing, because what you're talking about is whether you're using copy A or copy B, the old or the new, right? What you're talking about is embedding configuration options into that application that say, activate this feature or activate that feature.
So we could use a rolling deployment at all
Right.
times, and we just trust the deployment concept because everything's
Right.
feature flagged.
Right. So the deployment concept to me is separate, and the feature flagging thing is something that a capability you bake into the application, and the configuration that rolls out with that new version. So when you introduce a flag, right, you would introduce a configuration item in the new copy, and basically, it's the rest of the patterns apply. And with that, I'm not going to eat into anybody else's time. If you have other questions, I'm not trying to slough anything off. Tag me, I'll be around. Thanks for coming.